for cutting off lens. Cutting off a lens deform. Suppose if we have a lens, if a student cuts this lens, he will cut it normal to the optic axis. If we cut this into two parts, okay, you see this is, I cut this symmetrically into two parts. You can see here, the focal length of this is f, f dash, and f dash. Radii, let it be r, r, let this be mu. Then we know 1 by f equal to mu minus 1. This is incident ray. Then the ray will first strike this surface, so therefore plus r minus r. So what is f is equal to? F should be equal to r by 2 mu minus 1. What is f dash will calculate? F dash will be mu minus 1. The material, the mu will not change. So what is this f dash? F dash will become r by 2f, it will become. So therefore, if you cut the lens here vertically normal to the optic axis, the focal length will increase, will become double. So sir, if I cut it here not into two equal parts, if it is not cut into two equal parts, we'll see what will happen. It is not cut into two equal parts. You can see this. Still the focal length will be f dash and f dash. Where you are going to cut this lens, either here or here or here, it doesn't matter, sir. Of course, this will not have focal length, because here you look at this. This part will have focal length f. This part will have different. So if you look at this lens, actually this part will have focal length f dash. This part will have focal length f. Okay, in general, I'm writing it this one. Whereas this will have focal length f dash here. This part will have f, and this other part will be f dash. I think I'll better show it here this way. Okay, now if you cut it this way. Similarly, same thing with the concave lens, diverging lens also. Even with the diverging lens also, the condition is same. So if you take the diverging lens, And if you cut that into two equal parts, so let the radii be r mu r. The focal length of this will be, and we know that f should be equal to minus r by mu minus 1. Now when you cut this, okay, this will become f dash, f dash, this is r, this is r, this is mu. So what is f dash? F dash will be minus of r by mu minus 1, which is nothing but again 12. Either convex or concave lens. When you cut it normal to the optic axis, the focal length will get doubled here. If you cut them horizontally, if you cut them horizontally, if this is the lens, if you cut them horizontally, horizontally means somewhere here. Anything will happen to the focal length of those two structures. So by cutting them parallel to optic axis, so we are cutting them parallel to optic axis. Earlier it was radii r mu. So what is the focal length of this? R by. Now what happened? The focal length? Focal length will not change because focal length depends on what? Radii and the refractive index. If you cut parallel to optic axis, none of the parameters got disturbed here. The focal length will not change. Even if you cut this into some several parts, not only this, you cut this lens into several parts. All focal length of those parts will not change. The reason for that, because the cutting axis is parallel to the optic axis. So focal length of this will be f, f, f. So there's a one small basic idea, huh? What we should know better. Now, if a lens is made up of different material, uh, discuss in the next page. Now, next we have if the